Yeah, don't worry, anyone. We do have audio, but we'll be beginning very soon. Good morning, good afternoon, good evening, depends where you're joining from today. I'd like to welcome you to this online session that is really, really exciting today because we are going to have this great discussion about how utilities across America plan to leverage the hydrogen economy. And seriously, for me, like this is the great part about my job, is that I get to learn and speak to all of these amazing experts in the industry who you're going to meet very, very shortly. I just wanted to welcome everyone to this online session, and I'd like to ask you to please introduce yourselves. Just use the chat, introduce your name, your company, and where you're joining from today, and I will begin. I'm not going to use the chat, but my name is Belén Gallego, and I work for RENMAD by ATI Insights, and I'm going to be the moderator today. And also, I'd like to talk to you about this event that we have planned in Las Vegas for July 12th and 13th. You've just seen a little bit of the running now. We will send you a link through the chat so that you can see more information about the event, and I hope you can join us because some of the speakers will be there. I've not most of them, and we will discuss this topic and many others in great depth. If you're working in hydrogen, you're probably interested to come, so get in touch and come to the event. In the meanwhile, enjoy this session because it's going to be super informative, and most importantly, it's going to put you in touch with the right people with the right knowledge in these utilities. So first, I'd like you to get to know a little bit the experts that are going to be talking today. So I'm going to ask them to introduce themselves. Chris, please, if you could introduce yourself so people get to know you a little bit better.
Yep. Hi, my name's Chris Dancy. Work with NV Energy as part of their renewables development team.
Thank you very much, Chris, and welcome. We're going to hear from Chris very shortly and also the rest of the speakers. Next, I'd like to ask Jamie to please introduce yourself.
Good day. I'm Jamie Randolph. I'm Principal Hydrogen Program Manager at Pacific Gas and Electric Company.
Excellent. Thank you very much, Jamie. Next, I'd like to ask Kevin to please introduce yourself.
Aloha, Kevin Nishimura from Hawaiian Gas, Vice President of Operations.
Excellent. And next, please, Yuri, if you can introduce yourself.
Hello, I'm Yuri Freedman. I'm a Senior Director of Business Development at Southern California Gas Company.
Excellent. Thank you very much, guys. So now you know who's going to be speaking today. And I mean, you have them on screen as well if you like to see. But I can see there's people from everywhere over in the US. We have pretty much from everywhere, from Florida, Arizona, I see California, I see Vegas, I see Connecticut. Welcome, Arizona, even from Canada. And I'm sure there are some people also from abroad. So please keep introducing yourselves. We love seeing where people, are from and where are located. It really makes it so much more human, that we are here talking to you guys. So just to give you a little bit of information of how we're going to be doing this session today, we're going to have short presentations about 5, 7, 10 minutes ish. And then after that, we're going to have questions. We're going to have a Q&A. We have prepared questions, of course. We would be irresponsible if we were here and we hadn't prepared something, but that's not the point of this session. The point of this session is that you get to ask your questions. This is where you're live, and you will get to really bring to attention those issues that you think are important, relevant, or where you want clarification. You seldom get the opportunity to ask these 4 amazing experts from these 4 utilities questions, on a day-to-day basis. So please take advantage of this opportunity. To send your questions, instead of using the chat, I would appreciate if you could use the Q&A box at the bottom. It makes it so much easier for us to manage. And that's it. And just to remind you that we are recording the session. It will be available for you to watch again, to send to your colleagues, and also you will have access to these materials. So worry not, you will get an email with all that information. And without further ado, I just like to ask Chris to please prepare your presentation, take your mute off, and we will begin with the session proper. And don't forget that very much this is a give and take. So if you send us your really amazing questions, then we'll be able to really create some really nice conversation going. Chris, go ahead.
Well, thank you very much. Welcome, everyone. Let me get this presentation shared.
Yes, if you can just put this in, perfect. Go right ahead, Chris. We're ready for you.
Again, my name's Chris Dancy. I'm part of the renewables development team at NV Energy. Today, I'll be talking about hydrogen as an energy storage vector for utilities. NV Energy has a long history in the state of Nevada. We're the primary utility operating in the state of Nevada. Our roots date back to the gold and silver mining days, where we provided power to those initial operations. Today, we've grown to having over 1.5 million customers. We service over 46,000 square miles. We're also proud to provide power to over 40 million tourists that visit Nevada and mainly the Las Vegas Strip annually. And it's important to keep those lights on at all time. We were acquired by Berkshire Hathaway in 2013. With the combination of the Berkshire Hathaway acquisition and the renewable portfolio standard in Nevada, we've made it a very strong goal of ours to be able to provide renewable power solutions to our customers. In 2022, we were 8% higher than our 29% standard, with a total renewable portfolio supply of about 37%. Currently have 55 projects supplying power to our customers. Of course, the majority of our renewable power comes from solar. We have significant land resources in Nevada, and obviously there's a lot of sun here. We also have significant geothermal assets. Interestingly, Nevada, there's some areas that are below sea level, so the crust is very thin. That enables us to focus on geothermal. And of course, some biomass, methane, waste heat, hydroelectric, and very minimal wind. Currently, we have 2.5 or 2.6 gigawatts of solar and about a gigawatt of battery storage under construction or pending regulatory approval. A major initiative for NV Energy today is the construction of a high voltage transmission line called GreenLink. GreenLink triangulates the state of Nevada and interconnects high demand centers with rural areas of Nevada that are well suited for renewables development. We're focusing a lot today on the acquisition of land along the GreenLink corridors in order to expand our renewable assets. We believe a portfolio approach will be important as we transition to a carbon zero company. We're planning on focusing on the addition, of course, of more solar, but also geothermal, wind, pumped hydro, gravity-based storage technologies, and of course, what we're here discussing today, hydrogen technologies. This matrix of energy solutions, we believe, will best meet our customer needs and fit our load shapes. Hydrogen storage provides us with interesting opportunities and helps mitigate some of the problems that are prevalent with renewable resources. With hydrogen, you can utilize excess power to produce hydrogen and then store that hydrogen to smooth out the need of power on a daily basis, and it's able to provide longer term storage solutions. A common problem for us, and something that I'm sure most folks have heard about, is the duck curve. The majority of our renewables come from solar. And so during the periods, during the day, of course, we're able to generate solar, and during the evenings, you're not able to produce as much solar. And so the question is, how do you smooth that supply out? And so with hydrogen, we could take excess power that's produced during the days or the curtailed power, produce hydrogen, store it, and then utilize it, during other parts of the day when there isn't as much solar generation available. Another solution that hydrogen provides us is seasonal storage, longer term storage. We tend to overproduce from our renewable sources during the springs and falls, and do not produce sufficient amount of renewable sources during the summers and winters needed to meet our loads. Hydrogen will give us the opportunity to store excess power that's again produced during the springs and falls, and we could store it in the long term and utilize it as needed. We produce today about 4.5 gigawatts of power from natural gas. Our goal is to transition to a carbon-free utility by 2050. And of course, to do that, we'll need to phase out the consumption of natural gas in our natural gas processing facilities. One way to do that is to modify the facilities in order to use increasing amounts of hydrogen feedstock. Today, our turbines are able to process about 10% hydrogen mixed with natural gas. After 2025, we should have the ability to operate up to 15% or even greater concentrations of hydrogen blended with our natural gas feedstocks. Our goal is to have an integrated solution whereby we would take curtailed energy, utilize it in an electrolysis process to produce hydrogen, store that hydrogen, and then use it to help the inefficiencies on a daily basis as highlighted by the duck curve, or to help with some of the seasonal fluctuations that we have. We can burn the hydrogen in gas turbines, and when you burn hydrogen, it's emissions free. It basically just produces water. And it'll allow us to provide a zero carbon solution to our customers 24/7. There's many opportunities to further the development and to further the development of the hydrogen market today. In Nevada, our key concern is water. Of course, we live in a desert, a very arid climate. There isn't very much water to go around. So we need to make sure that we're conscientious of projects that we build that consume water. An opportunity for technologists and producers of hydrogen would be to come up with solutions to produce hydrogen in a less water intensive manner. Currently, there's also a moratorium in Nevada whereby we're not allowed to use liquid cooling solutions. We have to use air cooling. And so if there's a means to provide cooling or supplement the hydrogen, the water feedstocks with a less water intensive process, that would be very interesting to us. More specific to storage, the compression technologies today are very energy intensive. If we can come up with solutions to compress and store hydrogen in a manner that's less energy intensive and potentially more environmentally friendly, that will help push the development of the industry specific in Nevada. Speaking a little bit broader, there are other avenues for improvement within the hydrogen storage space. Of course, metallurgy and material science is a significant area of focus today. As you increase hydrogen pressure in pipelines, for example, the likelihood to having cracks or issues with the pipelines increases. And so if there are improvements to metallurgy or pipeline infrastructure or storage infrastructure, that'll help enable the storage of high pressure hydrogen without having some of the problems that exist today. That would be, again, very, very helpful. There are means to also bond hydrogen with other physical other elements, and that's where a lot of the technology and focus is today as well, is to more efficiently store this hydrogen. Of course, developing additional infrastructure, folks starting to spend cash, designing, engineering, and actually constructing facilities is important today, along with improving electrolysis technology and hydrogen turbines. We believe that hydrogen is a very interesting solution that will help us achieve a carbon neutral economy going forward. And we are excited to see how hydrogen will fit within our strategy and our growth moving forward. Thank you very much.
Sorry, I was just struggling here with the mute button. Thank you very much, Chris. I'm looking forward to see. I mean, there is a lot of plans there, but it seems like seasonal storage and utilization of what's now curtailment of the duck curve is like a very good reason to use hydrogen. And I definitely agree with you that water is an issue, as we know, and we need to find ways to utilize the least water possible for sure. So thank you very much. There are a few questions already there if you want to take a look, okay, more upcoming. But I'd like to ask Jamie to please go next. Your presentation is next. Make sure you take the mute off your microphone at the top there so that we can hear you. Thank you very much, Jamie. Go right ahead.
All right. So I introduced myself earlier. I'm with Pacific Gas and Electric Company. The slide's not moving. There we go. So a little bit about our company. We're one of the largest dual fuel utilities in the United States. We cover about 70,000 square miles and serve 16 million Californians. We've long been a leader in renewable energy, and we're working to decarbonize our gas system as well. We've reduced emissions from our gas system 24%, more than 24% of what we had in 2015, and we exceeded our commitment to reduce it by 20% by 2025 last year. As part of our climate strategy, we plan to transition to cleaner fuels and increasingly target hard to electrify customers and sectors to support the electrification. Part of our climate strategy is to be at net zero by 2040. And that's going to be impossible by a combination of maturing technologies, updating our infrastructure to enable a diverse supply chain of cleaner fuels, and looking at regulatory and financing innovations geared towards reducing unnecessary new costs from the energy system and recovering necessary costs in sustainable, equitable, and affordable ways. This is going to take a very diverse mix of resources, from electrification, cleaner fuels such as renewable natural gas and hydrogen, and nature-based solutions, carbon capture, storage, and utilization. So in our climate goals, one of our goals in 2030 that you can see here, this is from our climate strategy report, is we're prioritizing the readiness of hydrogen blending in 2030 climate goals. So we have a facility called Hydrogen to Infinity, and we're in our early design phases right now, and we will plan to have it operational in the next couple of years. So Chris did a great job of covering why hydrogen, so I'm not going to spend a lot of time here, but for PG&E, this is relevant for multiple reasons. One is for that enabling that large scale renewable integration in generations, that we can take that excess renewable electricity that California and Nevada have, turn it into hydrogen, and then use it for multiple things, not just for energy, but long duration energy storage is certainly one, blending into our gas system to decarbonize our gas system. And then also seeing, the decarbonization of our transportation industry, light duty and heavy duty vehicles, marine, rail, industrial uses, and building heat and using it as a clean feedstock. So Chris covered this pretty well already, how we would use hydrogen for clean firm power in his slides, but we're looking at using hydrogen, producing it from multiple ways, not just through electrolysis, but that is one of the ways that we could take advantage of that renewable electricity. But there's other processes that we can also take advantage of and use that hydrogen for that production. And electricity can be produced through fuel cells or through gas turbines. The gas turbines can either be blended natural gas and hydrogen, or they can be 100%. Most of what I've seen from utilities is that we're starting with a blend and moving towards that 100% hydrogen down the road in the future. And that will help us to have that clean, firm power all year long, even though the renewables out there are intermittent. So, and our highest priority with this is making sure we have safety, integrity, reliability, and resiliency in both the gas and electric system. So a couple projects I'm going to talk about briefly. One is on our electric side, we have a collaboration with Energy Vault. They are in the process of putting together a hybrid system that will be capable of empowering the city of Calistoga, about 2,000 customers. It's just under 2,000 customers within PG&E service territory. This is a microgrid that has both battery and liquid hydrogen. It's initially going to be able to power the city of Calistoga for 48 hours, 293 megawatts, but they're looking at expanding it to about 700 megawatt hours. Sorry, 293 megawatt hours. I think I said megawatts. It's actually 8.5 megawatts. Sorry about that. So this is the first of its kind, integrating short duration battery system for grid forming and black start capabilities, along with long duration fuel cells using green liquid hydrogen. So they'll be storing liquid hydrogen on site there. And let's see, you can see the site is going to be, I don't know if you can see my cursor, but it's in that bottom right-hand side where you see the stars. There's a green and a red star there. And they'll be managing it through a system that Energy Vault has, a technology system that optimizes the performance and safety. Currently, the project has a 10.5-year agreement, and construction on this is going to begin in the 4th quarter of this year. And it is supposed to be in commercial operation by the end of 2024. Hopefully the middle of the year. Q2 is currently the Q2, quarter 2. So the first half of the year is their anticipated date, but things don't always stick to schedule, as we know. The California Public Utilities Commission recently approved this project to proceed forward, and we're looking forward to it and very excited to see how we can leverage this pilot potentially to use this in other areas in the industry. Another project that PG&E is working on, I mentioned earlier, is the Hydrogen to Infinity project. This is a large-scale research demonstration, education, and market activation project for hydrogen blending in the natural gas transmission system. The primary goal of the Hydrogen to Infinity project is to lower the carbon footprint of the natural gas networks, gas-fired electric generation, and natural gas users, while reducing the cost of hydrogen as a fuel by determining factors needed for safe use of the existing infrastructure for long-distance transmission of hydrogen natural gas blends. Being able to successfully demonstrate a safe approach would help us to minimize the need for permitting and construction of new capital-intensive investment in pipeline networks to deliver hydrogen at scale. So Hydrogen to Infinity would fill a critical safety and system integrity information gaps. Right now, there's a lot of information that we're not sure how it's going to work to keep the system running safely. We know a lot of stuff, but there are a few things that we're still learning, and we want to advance our understanding in a real world situation. A lot of it's been done in paper studies and lab environments or small scale. So we want to bring this to large scale and see how it works in a real world environment. It's a standalone system. It will not be serving our entire system. It's only going to serve an electric generating facility that will be owned or is owned already by Northern California Power Agency, one of our project partners. Their turbine that they have at this facility can already blend up to 45% hydrogen. And so they plan to produce electrolytic hydrogen, and they are going to give it to PG&E to put into the standalone transmission system. We will blend it. We're going to work up from 5% to a 30% blend. We will be giving back to them that blend to put into their turbine so that they can learn how to manage their turbine with the blended gas. Another offtake we have is hydrogen fueling stations and compressed natural gas fueling stations. The purpose of this is twofold. One is for market activation of hydrogen fueling stations in that area of California. They don't currently have hydrogen fueling stations. And also is to demonstrate the ability to use hydrogen separation technology so that we can separate hydrogen out of the natural gas at a delivery point for those consumers and end users that need 100% hydrogen. And so we can pull it out of a blended natural gas system. This project also has a lab facility and offline full-scale destructive testing. We'll have a training facility and education center that's open to the public as well. So that's all I've got for today. Thanks for letting me share.
Thank you very much, Jamie. Very interesting projects that you have in there, and you're testing a number of things that I'm really interested in. I think everyone is to hear, how you guys are getting on in your projects and where you're finding. Shall we? There is some questions also for you, so that and someone here is congratulating you for using multiple pathways to hydrogen. So people are liking your message here. Next, I'd like to invite Kevin to please come up and with your presentation. Here we go. Yeah, perfect.
Thank you. Can everyone see that?
Yes, perfect.
Excellent. Again, aloha from Honolulu, Hawaii. Hawaii Gas, I'll just give a quick background on Hawaii Gas before I get into the hydrogen presentation. Hawaii Gas is Hawaii's only gas utility provider. We service 68,000 customers statewide with both utility and non-utility gas, which is typically propane. I'm going to focus most of the talk today on the utility gas system on Oahu, which services about half of those customers, so about 34,000 utility customers that are residential and commercial. This system feeds about 3 BCF of gas per year. I know for Jamie, that's probably less than what they serve in a day, but for the scale of Hawaii, where we don't have space heating, most of that energy is used for cooking and water heating. Let me advance my slide. So Hawaii Gas has been in business since 1904, and we started making synthetic natural gas in the early 1970s. We built an S&G plant adjacent to a refinery that the company that owned Hawaii Gas at the time also owned the refinery. So we decided to build this plant so that we could utilize one of the refinery products, naphtha, as our feedstock to produce synthetic natural gas. When we decided on the technology for the plant, which uses the Lurgy process, that process generated basically a product of about 80% methane, about 10 to 15% hydrogen, and the remainder was carbon dioxide and carbon monoxide. At that time, we decided that rather than stripping off the hydrogen from the gas, we wanted to see if it were possible to just leave it there, because hydrogen is energy too, right? So instead of investing money in removing those molecules, we said maybe we can keep it there and utilize that energy. So they did some testing, they did some research, and decided that that concentration of hydrogen in the gas would not affect the appliances. So we decided to leave it there. I think that was a pretty good decision looking back on it. And I wish we could take credit for, having the first decarbonization effort back in the 70s. But in actuality, now looking back, it was actually a benefit to us. So the SNG plant is, again, it takes naphtha from the refinery, which is a refined oil product that there's no market for in Hawaii. And we crack that naphtha into methane. It's designed for about 100,000 therms per day, or again, just over 3 BCF per year. And the heat value of our final product is pretty close to natural gas, just under 1,000 BTU per cubic foot. Our transmission and distribution system, this is what a lot of people are interested in when it comes to blending hydrogen with natural gas. We operate a 22-mile transmission line on Oahu that goes from our SNG plant on the west side of the island, brings the gas to Honolulu City, which is in the center of the island. It's 22 miles of 16-inch diameter yellow jacket pipe, X52 seamless. It has an MAOP of 500 PSI, and we typically operate the pipe at about 350 to 480 PSI on a daily pressure cycle. I know this is getting a little technical, but people ask, what is the SMICE of that pipeline? Because as Chris mentioned earlier, there's some concerns about the effect of hydrogen on steel pipe and embrittlement. Our understanding is that the embrittlement becomes more of an issue when you operate at higher SMICE. This transmission pipeline is operating at just over 30% SMICE and has been doing that since its initial construction in 1974. So almost 50 years now of moving a hydrogen blend gas at transmission line pressures. Our distribution pipelines, pretty standard for natural gas service. We have 1,100 miles or so of both PE and steel pipelines. About 60% of that pipeline is high density polyethylene. The remainder is steel, coated steel, bare steel. These pipelines range from a ½ inch in diameter up to 10 inches in diameter. And typical operating pressure of the distribution pipeline system is about 12 PSI. So relatively low pressures for gas distribution. In terms of the other equipment for distribution, meters, regulators, valves, we use basically what we see industry-wide in the United States. The typical brand names that you would expect, we use the same. These meters, regulators, and valves have not been modified in any way. We buy them basically straight off the shelf from the manufacturers for natural gas service. And over these 50 years, we haven't experienced or found any evidence that the hydrogen blend has had any impact on the life or performance of meters, rigs, or valves. So the usual suspects, diaphragm, turbine, also rotary meters, the typical regulators that you would see in service across the states, and also PE and steel plug and ball valves. So nothing really interesting to report other than the equipment and the pipelines that we operate here in Hawaii, just like those in the mainland for natural gas service. Finally, from our experience, most people, after we talk about pipelines, meters, and valves, are wondering about the end user appliances. So our experience over the years with both commercial and residential customers, all of our customers have been buying appliances made for natural gas service, whether it be cooking equipment, water heaters, boilers, our favorite tiki torches, all designed for natural gas service, and all have performed well and safely over the 50 years with our blend of typically 10 to 12% hydrogen. We have not seen any impact to the appliance life cycles or their performance or their safety. So it's an uninteresting thing to report. I think everyone is interested to know if we start blending hydrogen, are we going to have to modify appliances? Are we going to compromise their safety or their performance? And we're happy to report that there's no evidence of that, at least for the population of appliances that we've operated here in Hawaii. The only exception that I don't have experience with is space heating. Because our coldest day in Hawaii is just under 70 degrees Fahrenheit, we really don't have a need for space heating. So we have not had any experiences with furnaces. But again, in a nutshell, what our experience has been with blending hydrogen and natural gas is that we've operated ourselves like a natural gas company. Our customers have not been impacted in any way by the hydrogen blend. And in fact, for the bulk of the 50 years that we provided this hydrogen blend, most of our customers have not even been interested that they've been getting hydrogen. Only more recently, with all of the attention on hydrogen, are we getting a lot of attention from the industry and from a few customers. But I think I like to call Hawaii Gas the 50-year-old guinea pig, and we're still alive. So not knowing that we're an experiment from 50 years ago has not affected our ability to deliver safe and efficient gas. And that's all I have to share with our experience. I'm trying to keep it short here, but open to any questions and appreciate the opportunity to share with you. Thank you.
Thank you very much, Kevin, from getting into such detail about the tubes and Brightman and all of the technical issues of having a 50-year-old experiment. It's just not a small thing to say. And I think this is the thing with energy, right? If it all works right, no one really notices. It's only when it goes wrong where people notice, or when they get the bill and they have to pay. So thank you very much. We keep going with the presentations, and we'll take the questions at the end. As you can see, the presentations are really, really interesting, and we're seeing a lot of different experiences across the country. So Yuri, you're the next one up, and I'm sure you're going to surprise us as well.
Thank you so much for definitely the bar is set high, and I'll try to meet expectations. Let me see if I can make the
yes,
screen.
We can see everything perfect. We can hear you, so go right ahead.
Excellent, thank you. So I have the privilege of bringing this all together, so to speak. I think the previous presentations were great because they gave you the perspective of the electric utilities and gas utilities. We at SoCalGas are a large, by many metrics, the largest North American gas distribution company. We serve over 21 million customers in Southern California. We have a very strong environmental commitment, and our mission is to build the cleanest, safest, and most innovative energy infrastructure company in America. And in furtherance of that, we have committed to reach carbon neutrality by 2045, including scope 1, 2, and 3, which obviously is quite an ambitious undertaking. So how are we going to accomplish that? This is a schematic which we put in our what we call Clean Fuels White Paper, which asks the question of how is carbon neutrality best reached in California? And unsurprisingly, for I think many of you, the answer was that it will take a combination of clean electrons and clean molecules for this neutrality to be reached in the most cost-effective, but also in the most resilient way. And I think a lot of excitement around hydrogen is linked to realization that the hydrogen is one of the preeminent clean molecules that can really supplement and work together with renewables on the supply side and serve the energy storage needs that Chris was talking about, but also be distributed and serve a wide range of users on the demand side. Frankly, do everything that natural gas does today, and more, providing the fuel for fuel cell electric transport. So this picture here has quite a lot, but the takeaway here is that we see the need for blended hydrogen, where hydrogen will be blended in natural gas networks. We see the need for dedicated hydrogen pipelines, the pure hydrogen, and I'll talk about this a little bit more, about the projects we are developing. We also see the need for some continued natural gas service, and to reach carbon neutrality, that will require CO2 transportation from the emission sources, or perhaps direct air capture and sequestration or utilization of carbon dioxide. So it's really the portfolio approach that I think is the most prudent and the most efficient way to go about solving such a large and complex problem as the climate change. I'll talk a little bit about how we see a role of utilities. Again, in our mind, we are providing something that will be needed not today, but also tomorrow, and maybe more tomorrow than today. And I'm talking about the energy resiliency, reliability of power supply. Intermittent renewables will require dispatchable power supply to bridge between the volatility of the intraday volatility, the duck curve, but also very importantly to bridge the intra-year or seasonal volatility of supply, where we are producing the balance of supply and demand is very different in shoulder seasons and the peak seasons, and that multi-month time frame requires a molecular form of storage to avoid losses. We do believe that existing infrastructure can help scaling up, most immediately with blending, and in the long run by combining existing and new assets to build the hydrogen infrastructure at scale. And we see three sectors as really important sectors of demand that can underpin that. And they are power. As many of you may know, Los Angeles Department of Water and Power is moving rapidly down the path of introducing hydrogen to their power mix. Manufacturing is really important. And again, not many may know this, but Los Angeles area is the largest manufacturing area in the United States. A lot of heat-intensive manufacturing that needs to find ways to decarbonize. And last but not the least, heavy-duty transportation. We in California, in Southern California, have the largest port in the nation. On a combined basis, ports of Los Angeles and Long Beach are 9th or 10th largest port in the world. Tremendous opportunity to decarbonize traffic out of this port, and not just to mitigate greenhouse gas emissions, but also to improve air quality. For us, a vision of what's possible is provided by European efforts, and specifically by the efforts called European Hydrogen Backbone, which was conducted by multiple European utilities from multiple countries over a period of time. And the remarkable conclusion that they've arrived to is that more than half of the continent-wide network in Europe apparently can be built using repurposed gas infrastructure assets. In my mind, that's something which we in North America have to replicate by conducting the nationwide assessment, but there's no question, looking at this approach, that the potential to use existing assets is vast. And frankly, in every sector of the energy industry that I'm familiar with, it's always cheaper and often faster to use existing assets as opposed to building new ones from scratch. So I think we owe our ratepayers, we owe to the society to explore options to apply our infrastructure in the cause of decarbonization. To that end, what we are doing at SoCalGas, among other efforts, we are developing a large green hydrogen pipeline project called Angelus Link. The concept of it is fairly straightforward. We have a lot of solar and wind resource. That resource is, however, rather far away from the demand centers. And so to produce green hydrogen from solar and wind, and to bring this at an affordable cost to the demand centers, we will need a pipeline. We are now in phase 1 of the investigation of the feasibility of this pipeline. We're involved in the pre-engineering, design, and environmental review, and expecting to conclude this phase and submit the results to the Commission, to the California Public Utility Commission, in about a year, followed by phase 2 and 3 of the projects. Again, lengthy process, very involved with the community, very involved with all the stakeholders. We all know that it's difficult and oftentimes lengthy to build large infrastructure projects. We all need to be aligned in the commitment and in the understanding of the needs for the projects, because that is the way to make that successful. Switching gears a bit, and not to belabor the point on blending, but there's a long list of efforts which is legitimately led by Hawaiian Gas, which, as Kevin has mentioned, has been a pioneer in the blending business. Again, large efforts underway across the country to explore blending of hydrogen into gas networks. That accomplishes multiple purposes. In my mind, among them is the need to scale up hydrogen really fast. Because if you look at the historical data, it takes usually a long time for the new commodity to enter the energy mix at scale. If we're aspiring to execute the energy transition in a compressed time frame, we really have to focus on these clean molecules, and we have to be expeditious in introducing them to the mix, obviously while making sure that it's 100% safe. So it's rewarding and encouraging to see large efforts on the blending all across the United States, as well as globally. Europe, Asia, Australia, the effort is truly global. And to recap, we believe that California is in a very strong position to embrace hydrogen adoption at scale. We are blessed with abundance of renewable resource. We also have categories of demand which lend themselves very well to decarbonization through molecules. Frankly, some of them can only be decarbonized with molecules. And it is a logical continuation of the build out of renewables in our mind to start coupling them with hydrogen production, because that is going to make sure that as we grow our renewable capacity, we're going to maintain resiliencies that our customers expect today and fully expect tomorrow. And we at SoCalGas, as well as other utilities in California, definitely look forward to contributing to that through our competencies, through our skill set, but also through our infrastructure, using this in a variety of ways, from our right of ways to the assets and our skills and our workforce, making sure that we can bring California into the zero emissions future. Let me stop here. Appreciate the opportunity to share with you that. Looking forward to the conversation.
Thank you very much, Yuri. Very interesting presentation, and thank you for presenting so clearly, essentially, what from SoCalGas and in California, you can do in terms of embracing hydrogen. Is certainly interesting. I think, as you said, you guys are in a very good position, and in general, I think gas utilities are in a good position to move in this direction. I'm going to get this. Okay, so we have a few questions open. We have about 10 minutes to talk, and luckily for us, a lot of the questions have been already answered. Chris, Jamie, Kevin, I think you've also been answering a few of them. However, I think it would be great if you can take a look and see, if there is any other questions that you want to answer. I think we have a few still open. The first question that I'd like to ask is one, like, just for clarification, I think, and from all of you, really, like, about infrastructure. From your own operations right now, how much of the infrastructure that you have you can use can be adapted for hydrogen, and how much do you need to build out, and what investment is that going to require? I don't know, Yuri, you want to start, since you were already talking about this?
Thank you. Yeah, this is something which we are working on right now, and we are hoping to have results of that analysis in the first approximation by the end of the phase 1. For now, I'll say that we really look up to other areas of the world which have done this work. We're in the middle of it. Again, the European hydrogen backbone is the effort I referred to, and it's what I put in my presentation is one page. There are pages and pages of work behind that, and I know that many dozens of engineers worked on this over more than a year. So I encourage the audience to take a look at those materials and review them. I would also say that ability to use existing rights of way is a very important factor because many of the rights of way which were secured in the past may be exceedingly hard, if not impossible, to obtain today, just because the load centers, especially the coastal areas, the densely populated centers, are making it really, really difficult to secure land for new projects. So I think repurposing those rights of way is every bit as important as repurposing the actual physical assets in the ground, pipe in the ground. And one more point I'll make is that if we're aspiring to make hydrogen a truly vibrant market where consumers can enjoy the lowest cost that's being produced and transported at, liquidity and the open markets and something that exists today for natural gas in the United States, in my mind, it's really important to set up a market for hydrogen that's going to have those characteristics where there'll be price transparency, there'll be open access to infrastructure, which is something that utilities like ours can provide. So to me, these market parameters are really important to set right to make sure that the benefits of cost reduction are going to fully accrue to ultimate consumers.
Yeah, absolutely. I mean, we need infrastructure in order to create a market. This is what we're getting at, correct? Because if you don't have an infrastructure you can tap into, then you have two jobs to do. You have to produce the stuff, and also you have to transport the stuff. It's a much harder proposition. It just makes the job harder. If you have the infrastructure there, then you could just tap into it. It becomes a market like electricity would be. Yeah. So, and we need to get to that point, but of course we need to do it in a way that makes sense. That we're sort of like optimizing the investment as much as possible when it makes more sense, and so on and so forth. Jamie, I'd like to hear your view on this, or like just open
I
to
don't
the
have
rest
a
of
lot different answer than Yuri.
Fair enough.
We're actually, our utilities are working together because the California Public Utility Commission requires us to collaborate on this work. So we're pretty much in the same phase as SoCalGas in this perspective. We're in that process.
Working out what you need. Yep.
Yeah, we're working on it. We're assessing the assets. We're involved in lots of different consortiums that are also doing this, that are all over the industry. Some of them are worldwide consortiums. Both PG&E and SoCalGas are working on these. So we're not just working on it on our own by ourselves. We're trying to leverage as much information as we can with others and make it most efficient and affordable to get to the answers as quickly as possible. But we don't have those full answers yet. So we're getting there as quickly as we can.
Excellent.
Yeah, and so like I did see another question in the chat about like appliances and forced air furnaces. So same thing, we're still working through some of that. We know at lower levels there's been up to 5% end user appliances has been approved, like in the Canadian Standards Association. Hawaii Gas has shown it can work well, up to like 10 to 12%. When it gets beyond that, we're still in that R&D phase and testing things out and figuring out what things need to be altered. And, when we get to that higher percentage too, they're going to be phasing in new appliances, and older appliances are going to be replaced because they only last so long. So they're going to be building stuff to be able to handle these new blends because we're anticipating it far enough in advance.
And also, really high blends of hydrogen were not that rare. In town gas, here in some places in Spain, we still have it available, and it's 50%. And if we're working with normal cookers, you don't have to have a separate cooker for this. Unless there are things that we don't know about, and perhaps we're doing something really wrong. I don't know if it's the biggest a jump as we thought. Still some places in Madrid use town gas today, and it's not the only area. I'm sure you guys have experience with that gas as well. So, excellent. Okay, question for Chris, if I may. Chris, I wanted to ask you, if you had a magic wand, and you could put your ideal sort of situation for hydrogen development in Nevada, what would you prioritize, and how did you envision transforming that energy landscape for hydrogen?
Yeah, right now our focus is trying to identify industrial effluent so we can utilize, a wastewater stream to supply an electrolysis system. So for us, it's really all about water and where do we get the water from? Lake Mead, which is the primary reservoir that serves a lot of Southern California as well, in addition to Nevada, is very low. And so diverting additional water from Lake Mead is something we would never get regulatory approval on. And so we're working with local industrial centers to try to take that effluent water, figure out what we need to do to clean it up, and then be able to process it into hydrogen through an electrolysis system. So supply of water for us is really kind of the critical path and the most important aspect to a project right now.
And not a little one. It's something you have to focus on. So you know, in the chat, someone's told you that they have some technologies that don't use as much water, so perhaps something to look into. You
Correct.
never know. You know, technology will save us.
I saw another question on or solution to where you can convert seawater as well, which seems interesting. Of course, we'd have to transport the hydrogen to Nevada, but again, minimizing water use is very important.
So a question now for Jamie, if I may. It's a bit general, but it's like, what is standing on the way? What are the challenges of investing in hydrogen right now for you guys? Because there's so many things open, you know, there's so many areas to look at. So, and the funds are only so far. And even though there is a lot of federal funds, you know, what did you choose first?
Yeah, so I think one of the biggest is the infrastructure. There's a ton of projects out there for production. We know there's end users out there. In California, we have hydrogen fueling stations for light duty vehicles that sometimes can't get the hydrogen because they're not able to get it there in time. There's production, can't get it there. So I think that's one of the biggest things is that infrastructure. And one of the other things I saw recently that there was a study published by the Department of Energy. It's one of their pathways to liftoff on clean hydrogen. And they noted in there that currently today, there are enough production projects in process in the United States to meet the demand in 2030, but there's not the midstream and end user infrastructure in place to meet that same demand. So that's where they're seeing that there's going to be the bottleneck is getting that infrastructure in place. And then secondly, that report says that the cost to deliver that hydrogen to those end users is more than double than the production cost because of those other components. And so bringing down the cost of the midstream and end user infrastructure components is a huge piece of the project or piece of the pie that we really need to figure out. And that's why the gas companies are trying to figure out what is the most efficient and effective way to blend the gas in the short term, because it's a lot less costly if we can use existing infrastructure. Knowing that, you know, once we get down the road to 2045, 2050, that's probably when we'll start really needing more of that dedicated pipeline infrastructure. But as the demand ramps up, we need something faster than what we can construct. Some places will maybe be able to get dedicated pipelines faster. Yuri probably has quicker timelines on that than I do, but but that's where I see the biggest hurdles.
And of course, this is requires so many stakeholders to work together, right? And nothing is ever fast when it comes to like aligning all of these people together and all of these different institutions and interests. So I like the last question, because we're kind of out of time, to be about the future in a place where already 50 years of experience. So what's next for you guys in Hawaii, and what are you looking at? Because I mean, you can't wait another 50 years, you know, to go 100% hydrogen or to move, you know, to decarbonize. So what is next for you?
Right. So we are at Hawaii Gas, you know, looking to make these changes a lot sooner than 50 years. In fact, we have an RFP out now for both renewable natural gas and green hydrogen. Our intent, following the guidance that we're hearing from a lot of research going on, is to move closer to 20%. There's a lot of research and evidence that show that a 20% blend would work in our distribution system as well as with end user appliances. I'm hearing some of these appliances can even go up to easily 30%, but it sounds like 20% is a target that accommodates most of the population of appliances and end use. So that's our intent, is to move toward 20% at this point. I think the advantage we have with the history of blending the hydrogen in our gas allows us to increase the blend without overcoming that fear of just blending itself. So I think a lot of the challenges that our counterparts, like Jamie and Yuri, are seeing with regulatory agencies is that we already have the 10% in our blend. So that kind of gives us, an advantage there. But yeah, our plan is to increase it. We want to decarbonize our fuel mix moving forward, and we think hydrogen is one of the solutions.
Excellent. Well, thank you very much, Jamie, Chris, Yuri, and Kevin. I don't know if you want to say any sort of last words before we say goodbye, or maybe any. Okay, I just want to make sure if there's any final question that was there left. Thank you very, very much for your time. It's been really interesting to hear, your plans for the future. I know that the task ahead of us is immense. The reality is none of us is really quick. It's really daunting, to see all of this amount of work that needs to be done and all of the things that have to be changed. But it's not just us. There's a number of people, companies, stakeholders working in the same direction, and hopefully things will become clear, as the market develops. In the meanwhile, hopefully we'll meet you guys in Las Vegas for July 12th and 13th for the RENMAR Hydrogen event in the US. We hope all of you are there, and you'll see hopefully some of the speakers, at least 2, definitely going to be there, 3, and Kevin, you're also invited, so please come. So hopefully we'll have an opportunity to actually chat in person, and be able to make those partnerships and start talking, getting those stakeholders together for this goal. So thank you very much for your time once again, and see you in the